Hello everyone, this is Adel from OZ Engineering. In this video I'll show you how to run an antenna simulation in Ansys Discovery. In this example, I will simulate a patch antenna operating at 10 GHz and view its performance. I will start by importing the patch antenna geometry, which I have in a step file. So I'll go to Open, Browse, I'll select the patch antenna step file and click Open. Once we have imported our geometry successfully, the first step is to assign materials to the different objects. So here I'll go to the Refine mode. I'll expand patch antenna. Here I'll start with the substrate and I'll use Doroid. For the ground plane, we'll be using copper. And also for the patch, we will use copper. Now in the physics tree, if you select one of the materials, it will highlight all the objects that use that material. So here, if I select Doroid, it will highlight the substrate. Once we have our materials assigned, the next step is to create a port. So here I'll hide the substrate and the ground plane, and let's view it like this. To create the port, we need to go to electromagnetics. Under electromagnetics, select circuit port. Now, if you hover over the edge you want the port to start from, you see this yellow arrow. So click on the edge. Here we can set the port's impedance. I'll keep it 50 ohms. Now in the physics tree, we can see our circuit port, and also an electromagnetic region is created. So here we'll set the lower frequency to 9 GHz and the upper frequency to 11 GHz. Here our center frequency is 10 GHz. Now if I click on electromagnetic region, we can view it. The offset used in the electromagnetic region is simply λ/4 at the center frequency. So here 7.5 mm corresponds to λ/4 at 10 GHz. In the next step, let's add some local refinements to ensure the fidelity of the FDTD grid that will be created for the simulation. So I'll hide the substrate and the ground plane and select the patch and the port. Here I'll click on Local and I'll specify fidelity assignment of 0.1 mm. Now let's go to Simulation Options. Click on Electromagnetics Options, modify frequency points. For this simulation, let's set 3 far field points and 1 near field point. And I'll keep the number of points to 501. Now we are ready to solve the model. We don't have any errors. You can see this yellow hexagon. And we just need to click on this green Solve button. Once the model is solved, the hexagon turns green, and now we can view the results. So let's first plot the S11. So I'll go to Charts, S Parameters. This plots the S11, and you can see that the return loss is better than -17 dB at 10 GHz. To plot the far field pattern, let's click here. And we can also control how to display the far field plots. Since we selected 3 points of the far field, here we have 3 frequencies. So we can go and view the results for 9, 10, and 11 GHz. To view the FDTD mesh, let's click here. And here's our FDTD grid where the simulation was solved. We can plot other quantities. So let's go to Chart. And let's plot the total gain. This is the total gain in dB. We can edit this plot. We can also view the results for the other solved frequencies. In this video, we saw how to run an antenna simulation in Ansys Discovery, walking through the process from importing a step file of an antenna to viewing the return loss and radiation pattern. Thanks for watching, and see you in the next video.